Hello everyone, this is Siva. Our project is the smoke detection using IoT sensor data. We got the data set from the Kaggle. We have good amount of data, like around 62,000 data points. We did the pre-processing for the data and we actually concluded that the data is imbalanced and data contains more outliers and some of the columns are the correlated. This is the distribution, like data distribution for the output column. This is the correlation chart. And since the correlation exists between the columns, we didn't actually select a random column from that. So we did actually a feature importance based on that. We select the score. For that, we use that random forest to get the feature importance score. And from this chart, we can say that NC 0.5 has more feature importance. So I selected NC 0.5 over remaining correlated columns, not every column. We have a large amount of data, and using just simple try and test split doesn't give a good case to say this is a high. This model has high accuracy. Or this is the reason we actually use the k-folds. And since the data is imbalanced, that so we actually use the stratified k-fold. We use the different amount of data in each fold, like each fold contains like 62,000, we can say, divided by 7 fold. There are totally 7 folds data points in each, and data in each fold is data distribution in each fold is even. And these are the models which use logistic, random forest, support vector machine, k-nearest neighbors, radar boost, and gradient boosting. We got enough accuracy score from these models itself. That is the reason we didn't actually go for remaining models. And this is the output for each. This is the average score for each model. Like we gave more importance to the recall, since recall is very important in this case, because like there may be a scenario where smoke is not detected and still smoke exists. We have to minimize that scenarios. For this reason, we give more importance to the recall over remaining scores. From this, we conclude that random forest has a good amount of accuracy. And we use actually grid search to find the best parameters for the random forest. But if we find the best parameter, then we can clearly say that random forest prone to overfitting. This is not the case here. Like like most of the cases it overfits, but there is a slight amount of chance that it's not overfitting. To conclude that, we can actually do that again careful by using that model. It's like we can conclude from this that each fold giving the same amount of accuracy. This implies the random forest doesn't overfit the data. And this is totally about the random forest which we selected from the this is actually the server-side code. This is written in Python, and we actually use the fast API. This is because fast API is very simple. Mm, Fast API is simple, and it can from the name we can clearly say it's faster. This is the static folder, contains the static content like script styles and background image templates 404 and index.html templates. And Fast API, one of the good feature about the Fast API is that input and output is validated every time. The data is validated every time. Here the data is validated. This means that input, the type of input which we are getting from the front end, type of output which are returning from backend is should always valid. Like Fast API has an inbuilt feature for that. And this is the website. This is the introduction, which says an introduction about the project, and this is a form, we can say. It's not a form, it takes the input and print the output. For this, we actually sees that spreading smoke is detected, but we can change the output. Like, let's queue still smoke is spread. Okay, this may not take 1000. We can say temperature around 30. Oh, I guess smoke still exists. Give it to 100. Okay, I'm not. Let's give some humidity is decreased. This is the case where smoke is not detected. And this is our project, and thank you.